Okay, now we're going to graph part B, g of x is equal to 1/2 to the x power. Notice the entire fraction is raised to the x power. This is base 1/2. The graph, once we construct it, you're going to notice it's going to be very similar to this graph, 2 to the x. So let's go ahead and start. I am going to use the same x values to make my table. Okay, so same x values. Okay, but now I'm going to be plugging in to this equation. All right, I'm going to put it in a different color so that we can see the differences between the two graphs. All right, I am going to start like I did with the other one. I don't know, I just have a habit of already starting with x equals 0. So again, you can treat this as 1/2. You can think of it as 0.5. You know, you can use your calculator to help you plug in the points if you need to, but I will show you how to do it by hand. All right, so we're going to plug in 0 for x. So we're going to get 1/2 to the 0 power. Okay, and remember what we said a few minutes ago, anything raised to the 0 power is 1. So this is going to be 1. Okay, so this new graph will go through the point 0, 1. Okay, so let me put up here that we are making a table for 1/2 to the x. All right, so I'm going to continue with the positive x values. So now I'm going to plug in 1 for x. So I'm going to get 1/2 to the first power. Okay, that is going to be 1/2. Okay, so our graph will go through the point 1, 1/2. Okay, remember that's 1.5. Okay, so now we're going to plug in 2 for x. Okay, 1/2 squared. Okay, remember if you square something, that means you're going to multiply it by itself. So this is 1/2 times 1/2. Remember how to multiply fractions. You're going to multiply across the top and across the bottom. So 1 times 1 is 1, 2 times 2 is 4. So this new graph will go through the point x is 2, y is 1/4. And then our last positive x value is going to be 3. So this is going to be 1/2 to the third power. So this is 1/2 multiplied by itself 3 times. Again, to multiply fractions, you're going to go across the top and across the bottom. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So our last point in this direction is going to be x is 3, y is 1/8. And now we'll start plugging in the negative values of x. So up here, if x is -1, we're going to get 1/2 to the -1 power. Okay, so again, you know, you can use your calculator here. Okay, and I will show you how to do it by hand. All right, so if we plug this in, we're going to get 1/2 in parentheses to the -1 power in parentheses. You're going to get that this is 2. Okay, so this is going to give us 2. Okay, so we'll go through the point -1, 2. And I am going to come down here and show you how to do this by hand, how you can get the 2 out of this. Okay, so down here, I've got some extra room. So we're going to look at 1/2 to the -1. Okay, so you may or may not remember this, but if you have a fraction raised to a power, you need to take the top and raise it to that power, and you need to take the bottom and raise it to that power. Okay, so then we end up with 2 negative exponents, and we already talked about we don't like negative exponents. They're hard to think in terms of. Okay, so we want to eliminate them. Okay, so this is similar to what we did up here. Okay, but since you have 2 of them, what you kind of want to do is if you have a negative exponent, you eliminate it by moving it to the other place in the fraction. So for example, if I want to get rid of this 1 to the -1, I am going to move this from the top to the bottom and then change the sign of the exponent. And similarly, if I want to get rid of this negative exponent, I'm going to move the whole thing to the opposite place in the fraction, so from the bottom to the top, but I'm going to change the sign of the exponent. And so I end up with 2 over 1, which is 2. So that's where this is coming from. Okay, and you can do this for the remaining ones. So if I plug in -2 for x and I get 1/2 to the -2 power, we'll come down here and do the same thing. 1/2 to the negative 2, we're going to get 1 to the negative 2 power, and then 2 raised to the negative 2 power. We want to eliminate these negative exponents. So I'm going to move this guy to the bottom, change the sign, move this guy to the top, change the sign. So I end up with 2 squared over 1 squared, which is 4 over 1, which is 4. So this is going to give me positive 4. So our new graph will go through negative 2, positive 4. And then we plug in one more x value, negative 3. We're going to get 1/2 to the negative 3. We're going to go figure this out. So 1/2 to the negative 3. Raise the top to the power, the bottom to the power, and then let's eliminate the negative exponent. Okay, so we need to move this to the bottom, change the sign, move this to the top, change the sign. You're going to get 2 cubed over 1 cubed. This is 2 times 2 times 2, that's 8. 1 times 1 times 1 is 1. So you end up with 8. All right, so this turns into 8, and our last point is going to be negative 3, 8. So let's go ahead and plot our points. Okay, so we've got 0, 1. This one also goes through 0, 1. We've got 1, 1/2. You're just going to have to eyeball these fractions. 2, 1/4. 3, 1/8. And then if we go in the other direction, we've got negative 1, 2, negative 2, 4, and then negative 3, 8. Okay, so you're going to have a similar looking graph in that one side climbs very quickly and the other side gets closer and closer to the x-axis but never touches it. Okay, so the red one is the graph of 1/2 to the x. Okay, all right, so again, exponential functions, this is what you can expect from their graphs. Okay, one side is going to climb very quickly, the other side is going to level off somewhere. These two in particular leveled off at the x-axis, but remember, you're going to see in a few minutes you can apply transformations to these guys. So you might end up moving these graphs around. So you're going to level off somewhere, not necessarily at the x-axis. Okay. All right. So below the graphs, we have some fill-in-the-blank questions just to kind of make some observations about these graphs of the simple exponential functions. First thing to point out that both 2 to the x and 1/2 to the x, both of these graphs pass through the point 0, 1. Okay, reason being anything to the 0 power is 1. All right, next, remember A is talking about the base. As long as the base is not 1, we cannot have a base of 1, which we'll talk about down here. The function a to the x has domain what and range what? All right, we looked at 2 to the x and 1/2 to the x, but any simple exponential function is going to behave like this. Anytime your base is bigger than 1, so you could have 3 to the x, 4 to the x, 5 to the x, 6 to the x, and so on, it's going to behave like this blue graph. If you are dealing with a fraction, a positive fraction, so like 1/2 to the x, or 1/3 to the x, 1/4 to the x, 1/5 to the x, and so on, it's going to behave like this red graph. Okay, but if you notice, the domain and the range will be the same, kind of, for these. Okay, so both of these graphs, if you look at them, okay, so for example, the blue graph, our leftmost point is negative infinity, and our rightmost point is going to be positive infinity. These graphs cover the entire x-axis, okay, the red one included. So remember, if you keep going up, it corresponds to these x values, and if you keep going this way, you know it's covering all the x values this way. Okay, you can also see in our table, nothing got us in trouble for x. Okay, we plugged in 0, we plugged in 1, we plugged in positive values. For x, we plugged in negative values, and we were okay. So the domain of these simple exponential functions is going to be all real numbers, okay? And actually, this is going to be the case for any exponential function, okay? You're going to be fine if you're plugging in 0 or something positive or something negative. If you are dealing with an exponential function, its domain will be all real numbers, okay? The range will depend on the graph, okay? For these particular ones, for these simple exponential functions that I have drawn here, okay, if you go to your bottommost point, okay, both of these, the blue and the red, are getting closer and closer to the x-axis without actually touching or crossing, okay? So theoretically, you're getting closer and closer and closer and closer. So your y values are like 0.1, 0.01, 0.001, 0.00001, okay, and so on. So we're going to go ahead and just say that our smallest y value is going to be the x-axis, which has a y value of 0, okay? And then our high point is, for both of these, is going to be positive infinity. And as far as the endpoint on the 0, whether I put a parentheses or a bracket, remember, you never ever get to the x-axis, okay, where the y value is equal to 0. So since we never get there, we have to put a parentheses, okay? All right, another feature. There is a blank at blank. Okay, I know that's making a lot of sense of what goes there, okay? So what goes there, if you look at both of these graphs, whether it's the base bigger than 1 or the fractional base here, is that they both have a horizontal asymptote at the x-axis, okay? The x-axis for both of these is a line that the graph is getting closer and closer to, but never touching or crossing, okay? So I'm going to go ahead and write that in. For both of these graphs, there is a horizontal asymptote at the x-axis. And we are going to do a section on asymptotes, and you're going to have to learn how to write down the equation of the line, okay? So think about the x-axis. It's a line, okay? This is a horizontal line, so think back to section 2.2 when you learned horizontal lines. Okay, so the equation of the x-axis is going to be y equals 0. Since it's horizontal, it's y equals, and every point on the x-axis has a y value of 0. So I'm going to write that out to the side. The x-axis has the equation y equals 0. Okay. All right, next bullet. If the base is bigger than 1, meaning you're looking at the blue graph, this base is bigger than 1. 1/2 is not bigger than 1. So we're looking at something like the blue graph. Like I said, 3 to the x would look the same, 4 to the x, 5 to the x, and so on. Okay, so if the base is bigger than 1, then the function is an increasing function. Okay, if you travel this blue curve from left to right, you are rising the whole time. And then on the flip side, on the red graph, so if your base is less than 1, remember the base has to be bigger than 0, so it has to be positive, but it can't be 1. So if you have a fractional base, as in this case, so 1/2 to the x, 1/3 to the x, 1/4 to the x, and so on, you're going to get a graph similar to this red graph. And if you go from left to right, it's falling, so it's decreasing. So we're going to write that in. So if the base is between 0 and 1, these are numbers like 1/2, 1/3, 1/4, 1/5, and so on, you get a decreasing function. So finally, we're going to talk about why the base cannot be 1. Okay, so here's why. Let me see, I'm kind of out of room here. I'll do it white space right here. All right, if we had a base of 1, your function would be 1 to the x. Well, pick some x values. All right, so if x is 0, we'd get 1 to the 0 power. That would just be 1. If we plugged in 1 for x, we'd get 1 to the first power. That's 1. And then if x were 2, 1 squared is 1 times 1, which is 1. And then 1 to the third power is 1 times 1 times 1. So hopefully you can see that anytime I plug in an x value, the y value is always going to be 1. So I end up with a graph that no matter what the x value is, the y value is 1. And so I end up with a horizontal line. That is not exponential. Okay, so I'm going to write the function 1 to the x is a horizontal line through 0, 1, and that is not exponential. So that's why you can't have a base equal to 1.